I'm gonna go look at myself.
You want to start on the dot?
Yeah.
This is my first.
We'll give each other, like, people a few more minutes.
It's gonna be managed. That's right. You reach out to me and I'll. Well, there you go.
We're gonna be getting started soon. It's almost 2 p.m.
I'll get you set up. Okay, great. Nice to meet you. Okay, I'll go here.
And all the issues with the this one seems like it worked. Me? Yeah, I think this one was the one that had the issues with it. Yeah. Okay. And then once we start this session, yes. That's why I told Abigail to start. Oh, she started. Russian should be started. Yeah, the timer's running.
No, yeah, that's true.
Hi, everybody.
Hey, everybody. Welcome back. We're going to start session 2 now, marine debris education and community engagement. And kicking us off, we have Buzz Scott, who's going to be presenting a community education and research development initiative to develop new materials and uses from ghost traps.
Good afternoon, everybody. I'm Buzz Scott. I'm the founder of Oceans Wide, and we're a small nonprofit up in the Gulf of Maine. And we started out as an educational program, trying to teach kids about ocean exploration. So we would teach them to scuba dive and teach them to fly remotely operated unmanned submarines. Most of you know them as ROVs. And when we did, next slide, please. They went down to the bottom of the ocean and they started finding traps, trash lobster traps, ghost lobster traps, debris, all kinds of fishing debris. And they sat the vehicle down, the ROV down one time, and spun it around 360 degrees. And in Maine water, visibility is near zero. They found 6 traps. They landed right in the middle of 6 traps. And they brought the vehicle up and they looked at me, and I swore I was talking to Greta Thunberg. They said, "You've got to do something about this." I said, okay, well, let's do that. And we had school programs and summer camps. Next slide, please. We took them out on the boats. This is our newest boat. I'm very proud of her. She's a 38-foot lobster boat we use to recover traps now. Next slide. And on board that vessel, we have side scan sonar. The side scan sonar, we can look down at the bottom and we can literally pick out the traps on the bottom and then put our divers in the water and they go down and they mark the traps and then we recover them. Next slide, please. Our campers and students and staff, volunteers, found ghost traps that had washed ashore on the beaches and the coastline of Maine, and again said, we've got to do something about this. So I'm getting hit pretty hard by most of our students and staff, and decided that we'll take a little shift from education to environment. And we started taking traps from the fishermen, and we've in the last 5 years, we've taken 12,000 plus traps out of the environment, and I'll tell you a little bit more about that later. Next slide, please. Then we started talking to the fishermen. We thought, geez, this is going to be a tough sell. They're not going to like this. I went down to Jonesport, which is almost down on the Canadian border, and one of the fishermen said to me, "Get in my truck." I said, okay. And he started driving, and he kept driving, and he kept driving. We got about 10 miles inland, and he took a dirt road, and I thought, this is it. I'm going to be left out here in the middle of the woods. And he pulls up about 3 miles out into the woods, And for a half mile on both sides of the road, there's all these traps that they had taken up there and dumped and just left there. And he said, can you help us with these? And since then, we've had almost 100% buy-in from the fishermen. Number one, they like the fact that we're cleaning up their environment, helping them save their resources. And the third one, the really big one, we're working with their kids to help them understand the environment, to help them understand what they've got to do to keep their culture and their heritage and their livelihoods alive. Next slide, please. So in Maine, we have 5,000 fishermen. They have 800 traps each. Every year they lose about 10% of them, and they've been fishing for 40 years. So near case guess, we figure there's about 16 million traps on the bottom of the Gulf of Maine in just Maine waters. Next slide. We have, in the last 5 years, we started in Boothbay Harbor. We went up to Gouldsboro, and then the last 2 years we've got Matinicus, Vinyl Haven, and Stonington, and up in Jonesport. In Boothbay Harbor alone, we've taken 4,000 traps out of that little harbor, off the bottom of the harbor with divers. On Matinicus, we've got about 10,000 traps on a small island, the island that I grew up on. There are about 25 fishermen, and they have just put their traps over the 40 years onto the island, and I'm afraid it's going to sink. But there's 10,000 traps on that island, and we don't know how many are in the water out around that island. So we're going to start the dive next year to figure out how many are down there. Vinyl Haven, we got part of the VIMS grants. We actually got a VIMS grant. We'll be out there for 5 weeks in July and August of 2025. Anybody wants to come join us, come on out and we'll show you how we do this. Next slide, please. So this is not ideal, but this is Boothbay Harbor. The brown parts are the muddy bottom, the sandy bottom is lighter, the gravel and shell are another color. But you can see all the purple dots. Those are the traps that we have taken out of the water in the last couple of years. In the middle right there, there's a spot about the size of a football field, and we took 800 traps out of that one spot. Next slide, please. This gives you a little better idea of where the water is and where the land is. So, but not as many dots on this one. Next one, please. These are our fishermen that are helping us. They're using their vessels. They're taking, we go down with our divers. They mark the traps and they swim away. So they're out from underneath the boat. They're out away from the trap. And then the fisherman comes along behind and recovers those traps. Our best day yet is 100 traps, but every day we're at least 25 to 100 traps that we take out of the water. Next slide. And I want to say that 66% of the traps that we bring back are still fishing. 20% can go 66% have animals in them, lobsters, and 20% of these traps can go back to the fishermen. Another reason that the fishermen like what we're doing. Next trap. The next slide. This is our base up in Gouldsboro, and we have had 8,200 traps, give or take, come through that, and we process them on a daily basis. And every bit of those traps materials are recycled either to a metal recycling, or we're working with the Gulf of Maine, or the University of Maine, to find other purposes for the plastics. And it sounds like there's a lot of people in here that I could talk to about how we would recycle the plastics. Next slide. This is how we process the traps. Next slide. This is all the processed material. Next slide. We have rope, bricks, weights, all kinds of things, so we can repurpose all of those things. Next slide. And then working with the University of Maine, the Advanced Structures and Composites Center, we're trying to figure out how we can chip up all of those plastic bits and pieces, put it through their 3D printer, and create things that are useful to the fishermen, like boats, crates, and other things. So I'm going to stop there, and hopefully there's some questions. Thank you.
It's okay.
Thanks, Buzz. Really cool project.
Thank you.
I have a couple of questions. Are the traps that you got were in the woods, are those reparable at all, or they just have to be decommissioned?
No, those are all what we call trash traps.
Okay.
Yeah, end of life traps.
Okay.
Yeah.
And then the other question, this is like more of a fisheries question. So in Oregon, for Dungeness crab traps, they're required to have a cotton piece that like opens up so that even though they might continue to ghost fish, like things could technically get out. Is there any regulation like that in Maine? Or
Yes. Yeah, we have what we call escape vents. Great idea. But when a trap is sitting on the bottom of the ocean, those escape vents, the trap settles into the bottom, and the escape vents are actually in the bottom most of the time and don't get released so that the animals can get out.
Got it.
A lot of the fishermen down east put a wooden lath in the top of the trap, and that is the best way to do it because then the lath is eaten away by the worms and the animals can get out of the trap.
Got it. Cool.
Yeah.
Thanks.
Thanks.
Oh, sorry. Two questions related. Can you recycle the ones in that graveyard that the guy took you to at the end of the dirt road?
Yes, we can.
Oh, that's great. And then do you get some revenue from recycling the metal?
It costs us $600 to process the traps and get them to the recycler, and we get about $90 back per ton. $600 per ton to process, $90 from the recycler. It's not very economical. Thank you.
Yeah, I think so. I have a kind of a sonar nerd question here. I was wondering, are you recording your side scan data, and do you notice any association between where you're finding these pots and the substrate, preferentially in rocky or muddy areas? Anything that points to, the loss mechanism?
Yeah, so we haven't been. This all started as like I said, the kids said you've got to do something about this, so we didn't even know about the marine debris programs, and we just started the process. So we were using the sonar, we'd find the traps, and we would go down and get them. We're going to start recording those, but we haven't yet. And your second question was, do you see any particular, Yeah, so a lot of times they'll settle into the mud, they'll settle into the shelly, gravelly bottom. On the hard bottom, they'll tumble, and we'll find them washed ashore usually on those in those areas. Yeah, thank you.
Thank you for that. You mentioned that about 20% are reusable and returned to fishermen. Can you describe that process? Like, how do you contact the fishermen? Are they just the ones that work with you, and how do you get it to them?
Right. So the state of Maine Marine Debris, the Department of Marine Resources has a list of everybody and their tag numbers. And with their tag numbers, they give us their phone numbers. So we read the tag numbers on the traps, call the fishermen and tell them that they can come get their traps. They come get the traps and away they go. Yeah.
Thank you. That's all the time we have for questions. We're going to move on to the next presenter.
Thank you. Can I start with you? Where do you want me? Oh, I'm not.
Thank you. Great presentation.
Thank you.
Next, we have beach and on water trash trapping tech team for Lake Erie from Abigail, Comar.
Hello again. I'm Abigail Comar, the Marine Debris Outreach Specialist for Ohio Sea Grant, and today I'll be talking about our bottle project. Next slide, please. So we're based in the city of Cleveland. Obviously, Lake Erie is our coastline, and we're part of the greater Great Lakes Basin. Next slide. Shout out to our funders. NOAA is the funder of this specific project, but our technology is also funded by Meyer and the Council of the Great Lakes region. Next slide, please. And then here's our list of partners. Next slide. So the technology that we use, we have two trash trapping robots called the Bebot and the Pixie drone. So the Bebot is the one on the sand and the Pixie drone is in the water. They collect waste from the surface of the water and the surface of the sand. That waste is recorded, weighed, and counted, and that data is collected and submitted to the International Trash Trapping Network. But this technology, which I run on beaches, we also use in our bottle projects. So next slide, please. So BOTTLE stands for Beach and On-Water Trash Trapping Tech Team for Lake Erie. We work with Cuyahoga Community College has a program called the Youth Technology Academy, where they have, it's a voluntary program for Cleveland Metro School District high schoolers to take classes at the community college, do robotics programming. They have some robotics teams that they could beat, and it's an opportunity for them to get that extra experience outside of school. And so this project, we met the Youth Technology Academy at an outreach event and saw an opportunity for them to use actual robots that we use in the field. So the students get to learn how to use the robots. I teach them stuff about Lake Erie and marine debris, and every time they participate in an event, they get a small stipend. So a big part of this project was making it worthwhile for the students. These are Cleveland Metro School District students. They don't have a lot of resources to do this stuff on their own, and so you know, if they're taking time out of their day to be here instead of at work, it's really important to us to like make it worthwhile for them. Next slide, please. So last winter we had a Lake Erie lesson. A lot of the students, they don't learn about Lake Erie or the environment outside of like big picture science stuff in school. And so we had a lesson just about Lake Erie and how marine debris ends up in the water in Cleveland specifically. And they had a really great time. They always have lots of questions. They're smart kids. Next slide, please. Then in February, we had a training session for our Pixie drone. So it's the winter time. We don't run our robots in the winter, but the community college pool let us use the pool to do a training session. So they got to see how the robots work. Next slide, please. And then in May, they came to the Cedar Point Math and Science Days. It's an annual event for schools to come and learn about different programs that have tables like we did at the park. And so the students got an opportunity, again, to drive the robots, but also they were doing outreach at the event. Next slide, please. And then this was our big event this year. Ohio Sea Grant has a additional program called the Stone Laboratory. It is in the Lake Erie Western Basin Islands. OSU has a research lab where they do outreach, education, and research, and they offer field trips. And so we organized a field trip for our students in the Bottle Project to come. I think we did it over 2 different days, and they came, they did a science cruise, they did a fish dissection, and they got a tour of the island that Stone Laboratory is on. This was a really important event for our program. A lot of these kids, this was their first time being on a boat. So they took a boat from they took a ferry from the mainland, and then they took a water taxi to where the lab is, and then they went on a science cruise on a research vessel. So that's 3 different boats that they were on for the first time ever in their life in one day. Same with like, on the science cruise, we do not trolling, and they got to, yeah, they got to see the fish like they were holding live fish in their hands, which many of them don't ever do that. And so it was a really special day that they had a lot of fun just getting to interact with their environment in a way that they don't normally get to. Next slide, please. And then the other part of the program, they are robotics students. And so I use them to help me when I have issues with the robots. So this July, we were having some maintenance issues, some technical issues with the Pixie drone and its Bluetooth connectivity. And so I brought the robot into their robotics lab at the community college. There were some students there who we were on a call with the manufacturers who are based in the Netherlands. And, I helped unscrew some of the screws, but I let them take over. They were the ones talking with the manufacturers, doing all the tests to make sure that everything was working correctly. And so this is like work experience that they can say, hey, I did a repair on a real robot that gets used to clean the beach. And so that was a really fun opportunity. I don't have pictures from it, but I also had an issue with our Bebot in October, which they also helped fix. Every time I have something, I'm like, please help me. And they're always excited to help. Next slide, please. And then this was our other big event this year. So at the end of October, we had a Bebot training. The big push with this event was we wanted it to be at their local beach. So in Cleveland, Edgewater Beach is the city beach in Cleveland. And it required a lot of work on our end to get permission to have the robots here. And so it was really important for us to have them not only practice using the Bebot on the beach in the sand, but on their local beach. This is the beach they come to swim. This is the beach that they all know and love. And so that was a really important part of this training, was getting them at their local beach. It was great. We did a training of like how to drive the robot, and then they picked up trash, and then we did a full detailed waste characterization, and they got to see everything that they picked up, which they were very surprised about how much trash there, it's little pieces, how many little pieces there are in the sand. And then, next steps at this event, I had them take a pre-survey to assess their knowledge about Lake Erie, marine debris, and the trash technologies. And then at the end of the school year, they're going to take the same survey to see what they learned from the program. Next slide. And there's my contact information. And thank you.
Thank you for that. Great work. And sorry if this is kind of a silly question, but how does the robot differentiate between organic material that may be important to like dune preservation or other parts of the ecology of that system versus trash?
Yeah, so the robots do not differentiate. When they do a cleanup, it picks up anything that will fit in the mesh size, and then someone has to manually go through and pick out the plastic. And because of that, we only run it on beaches that are already disturbed. So like, I only am gonna use it on a beach that the beach does like raking regularly. So I wouldn't use it, on a sensitive location, just because it can't differentiate that.
Thank you. Really cool project. I just had a quick question. What size of plastic are you filtering? Is the mesh that's what can it trap?
Yeah, the Bebot, the mesh size is 5 millimeters, and the Pixie drone is 3 millimeters.
Great presentation. I had a question about your robot. First is, how much does it cost? And second is, I got high schoolers, so they join these robotics clubs, and their thing is they would build robots, pick up balls, and then do a basketball in a competition. Maybe you can do something where they can build robots in the competition, who collects most trash from the beach, as an example, right? So they can be involved in learning how to build robots and also cleaning our beach at the same time.
Mm-hmm. The first question, the Bebot, with like all of the extra stuff, is like $70K. And then the Pixie drone is like $30K. For the second question, yeah, that would be awesome. That's ultimately the goal, is that this project will inspire them to want to do stuff like that. I don't have the resources now to put on a competition in that way, but we are working on some like small scale lessons with them of like using, Legos or whatever for them to model how they would change the design of the robots to be more efficient.
Is the Bee-Bot available commercially?
I think so. So it's, who owns the Bee-Bot? I think if you go to Cereal Cleaners is the Pixie Drone, and it might also be the Bee-Bot. I can't quite remember, but yes, you can purchase them. There are multiple around the country. There's quite a few in the Great Lakes in the project that I have them from. But yeah, you can purchase them.
I think we have time for one more quick question.
Thanks. So I think you sort of hinted at what your answer to this might be. Do you see things like the Bee-Bot and the Pixie Drone as being effective debris removal devices or better used as educational tools?
My personal opinion is that they are better as educational tools. They're very labor intensive in terms of doing an actual beach cleanup, so they're pretty slow, and you have to empty them regularly. I'm trying to, like, the Bee-Bot could run, like on a Cleveland beach, which is pretty dirty, you could run it for about like 50 feet, and then you have to empty the basket and sort through it. And so when you just have one person, that could take hours to do even a small section of the beach. And so we do use it for the project with the Council of the Great Lakes region. We collect data on it, but I really see it as an educational tool of how can we design these robots better in the future.
Thank you.
Thank you.
Awesome. Next we have community science to address microplastic pollution in environmentally underserved watershed communities in New Jersey and New York by Diana Burich.
Thanks. Hi, everybody. My name is Diana Burich, and I'm happy to be here today to talk about a project that engages youth in community science actions. The Eco Ambassador Solutions Lab supports communities impacted by environmental injustice in New York and New Jersey by building skills for raising awareness of the pervasive problem of microplastics in the water supply. Next, please. The project is a collaboration between ocean researchers and education researchers at Columbia University's Center for Sustainable Development, extension agents at New York Sea Grant, and education professionals at New Jersey Sea Grant Consortium. Next, please. The main theme of the project is empowerment, with the ultimate goal of mobilizing young people to create change in their communities. As a citizen science program, middle school and high school students volunteer to participate independent of their schools. Geared towards adolescents, an age group that is exploring their identities and place in the world, Eco Ambassadors Solutions Lab aimed to provide experiences that could leave lasting impressions on participants, mobilizing them to create change. With two components, a virtual summertime engagement and optional in-person lab experiences, the program provided an opportunity for students to develop content knowledge and technical skills in a collaborative learning environment. All of the participants developed a final project that consisted of creating a story map that could be used as a tool to share with their communities to create awareness. Next, please. The theme for this year's program, entitled Oceans, Rivers, and Water Bodies in Our Backyard, centered it around Sustainable Development Goals 6, 13, and 14. Developed in 2015, The UN Sustainable Development Goals provide a roadmap to secure the rights and well-being of everyone on a healthy and thriving planet. The students looked at these SDGs in their own context. They articulated their own narratives and they created their own solutions. Next, please. Using EJ Screen, the EPA's environmental justice screening tool, we looked at communities with existing water quality issues, particularly those that are in close proximity to wastewater discharge sites, and those are depicted with the little brown dots in the map. The sites are in highly densely populated urban areas around New York City, where communities are disproportionately impacted by environmental hazards since they're exposed to more pollution than they produce and they have less access to green space. And there are actually hundreds of schools and communities, urban communities, within that little circle there. Next, please. In an effort to get the word out about this free program, it was promoted in a number of ways. The Lamont Doherty Earth Observatory holds an open house each October that engages public with fun hands-on activities. So this was used as an opportunity to generate interest, as well as flyers distributed at teacher workshops, emailed to school administrators and listservs, and social media posts. Next, please. These photos show the students participating in lab activities, which took place in April and June. Part of the project was, this part of the project was optional due to transportation barriers. The Lamont Doherty site is not in an urban neighborhood, so kids would either need to be driven there or take the intercampus bus transport. The participants are learning basic lab skills as they're working up water samples from their neighborhoods and also from the Columbia University campus pond. The kids analyzed laundry water as well, dryer filter lint, laundry detergent sheets, as well as some food items like shrimp and eggs. They worked with a researcher to develop protocol for analyzing water and food samples for the presence of microplastics. The lab protocol developed provides simple steps using easily accessible lab equipment and inexpensive materials that can be performed in any teaching lab and is being finalized to share more widely with educators. Next, please. Here, participants are using microscopy to analyze and measure microplastic particles from laundry water. The photo on the right shows a student using a fluorescent microscope, and you can see the glow from the particle on the microscope stage. Though these samples were dyed with Nile red, synthetic fabric dye can also be used to make the microplastic particles stand out a bit more. Microplastic fluorescence depends on the chemical additives in pigments and optical brightening agents used in some plastics, as well as temperature treatments. As a result, sometimes the particles can actually be seen using a simple UV flashlight. The photo on the left shows the girls discussing the results of their lab analysis. When asked how they felt about finding microplastics in their samples, they expressed concern, but they also said that they were excited and hopeful to do something about the problem in the future. Next, please. The online component consisted of 7 weeks of summer-long learning, Mondays, Wednesdays, and Fridays from 9 a.m. to 10 a.m., where the eco-ambassadors interacted with researchers, educators, and professionals during the sessions. They learned the basic science of aquatic environments and the behavior and prevalence of plastics in those environments. They gained technical skills by learning the fundamentals of GIS, interpreting plastic pollution data, and data analysis. And all of this comes together in their final project. Next, please. Story maps. So the students created story maps for their final projects. Story maps integrate maps, legends, text, photos, and videos into a functioning product that enables the user to explore content. Students chose an SDG and chose their own topic, and they used templates to complete the final product, so they didn't need to learn how to write code. And story maps are really a great way for students to use storytelling to articulate their neighborhood narrative and to build community advocacy. Next, please. Overall, the project partners were really pleased with participation for the program, where we were hoping to engage 50 students with the online course. We had an overwhelming response of applicants, 246, and accepted 118 students from 15 different countries. We were just shooting for New York and New Jersey. 42 students participated from 6 states. We had 24 students participate from New Jersey and 9 from New York. The students received certificates of completion, and select students have the opportunity to present at conferences. So as a result, the students not only gained content knowledge and technical skills, but they also built soft skills like community, leadership, and global citizenship. So we're hoping to mobilize them for change. Thank you. Any questions?
Really cool. Thank you. Really cool talk. Really cool project. So was the idea that the methods that they would use in the lab were ones that could be used in their high schools?
Yes. Yeah, go ahead.
And if so, is that something that you guys are sharing more broadly?
We will.
Awesome.
Yeah,
Thanks.
we're not quite finished with them yet. We're talking, let's say, use 100% hydrogen peroxide to digest the animal tissue. You're putting your sample then in, just kind of mixing it in a vortex mixer, and using a filter to just run the sample through the filter, wash it through with some dye, let the filter paper dry, and then look at it under a microscope. And we actually, New Jersey Sea Grant did a teacher workshop about 3 weeks ago at the New Jersey Science Convention. So Mindy Voss and I did a session on microplastics, and we field tested the protocol with teachers that were in the workshop. We looked at laundry water. We didn't actually have laundry water, we created it. We put a piece of nylon shorts in a beaker and agitated it, filtered it, and dyed it with the synthetic dye that you can buy on Amazon. RIT, R-I-I-T makes that, and there's another brand as well. And we did it in about 15 minutes with teachers in a workshop. So we're working on tweaking it a little bit more so that we can share it widely. Any other questions? Oh, go ahead, Carrie.
What story map platform have you found to work well with students that maybe are novices with making one? Like what do you prefer? Any tips in that regard?
I think that's a good question. So this project is actually building on a project that started during the pandemic. So the educators from Columbia University have a relationship with Esri. And so they utilize that platform, and those are the templates that the students used. Thank you.
Hi, so my question is regarding the requirements for joining the program. Do you have like age limit or any other requirements that you have set for joining the program?
It's middle and high school students, so 14 and up. And I have to admit, when the partners at Columbia said, we're getting a lot of responses and we should keep extending the application period. And I'm thinking, we have a summer to get this done, so we need to wrap it up. So as far as that goes, I think the online component had kids from all over the world, from Dubai, from Croatia, from Thailand. And I think that's a great component to the project because it brought kids from all over the world together, not just the kids from the States. But age requirement, I think, my personal opinion, and I think a lot of educators agree, there was a question that came up earlier about curriculum development and standards alignment. When you're developing lesson plans, middle school age seems to be the age that we shoot for because you can either provide more complexity for high school students or streamline it for younger students. So I really think that middle school and high school are like great ages to engage kids, to really get them passionate about what they're learning and making a difference in the future.
Thank you.
Thank you. Any other questions?
Quick question for me. Was this the first cohort kind of high school students?
No.
Okay.
So this, for this funding opportunity, yes, but this project started in 2019 as a way to engage kids during the pandemic.
Okay, and then I guess my follow-up is, have you seen sort of these students like go on to,
That's a really great question. And yes, the partners at Columbia have seen that. So there have been students that were high school students that participated in this program and went on to undergraduate work studying microplastics. Kids in high school have started environmental clubs. There were students that started letter writing campaigns to their legislators. So there's been a lot of impressive action from young people. So thanks. Yeah. Is this still going on? Well, the 2024 cohort is done, but it will be open again. So if you get a chance, I've had the links for the story map. I'm sorry, like I couldn't show one, but take a look at the story maps, and you want to look at SDGs Today, Eco Ambassador Solutions Lab. And that's where you'll find information. So if you know any students that are interested, please spread the word.
Thank you, Diana, and thank you for all the great questions. We're going to move on to the next speaker.
Next we have Fashioning a Model Response, educating members of the fashion industry about microplastics to reduce marine debris in local waters. Ginny, Carlton, and Leah, Holloway.
So our Fashioning a Model Response project is part of the 2024 cohort of community projects. So we're just getting started on our project. Next, please. I'm Ginny Carlton. I'm the Education Outreach Specialist with Wisconsin's Sea Grant. And earlier today, you met Leah Holloway, one of our project team members as well, who represents Milwaukee Riverkeeper. Others on our project include Jessica Frankel at Mount Mary University's Fashion Department, and then two of my colleagues with Wisconsin Sea Grant, Ann Moser and Deidre Perhoff. So we have a small team, but we believe it will be a mighty team with all of the collaborators and partners that we're working with, and are really anxious to get started on this hopefully really unique project. I'm going to let Leah provide an overview, and then I'll come back to you and tell you a little bit more of the details.
Thank you. All right, next slide, please. So hi again, welcome back to Milwaukee. This time we've got a map for you. So Milwaukee's population of over 560,000 people, and its location at the confluence of these three rivers, we've got the Milwaukee, Menominee, and Kinnickinnic, suggests that the city is likely one of the prime sources of plastic being introduced to the Great Lakes. So 22 million pounds of plastic are entering the Great Lakes every year. 11 million of those pounds are going into Lake Michigan, and we think Milwaukee is one of the sources of that. And then Lake Michigan is a source of drinking water for over 1.3 million people in the Milwaukee area. So this is impacting our health. Next slide, please. You've already heard some of these stats today, so I'll just run through them really quickly, but the fashion industry is likely responsible for about 1/5 of the 300 million tons of plastic produced globally each year. Approximately 100 billion items of clothing produced each year. Nearly 70 billion of those are made of plastic and are probably discarded within 1 year of being purchased and sold, or produced and sold. And then around 500,000 tons of microfiber, which is the equivalent of 3 million barrels of oil, is now being dumped into the ocean every year. So that's a lot of plastic going into our waterways. Next slide, please. So due to the small size of microplastics, a lot of water treatment plants are unable to remove some or all of these fibers, and these plants are releasing up to about 40% of microfibers that they receive into rivers, lakes, and oceans. And about 35% of the world's ocean microplastics are probably coming from the laundering of synthetic fibers. And that's still being studied in the Great Lakes as well, so we don't really know yet how much of that is contributing to the Great Lakes. But clearly, since complete removal is difficult, if not impossible, for these microfibers, it's pretty important that we try to keep microplastics from entering the wastewater treatment streams as much as possible. Another thing that I've heard from researchers looking at wastewater treatment facilities is that the sludge that's removed, which contains the microplastics, is then being used as fertilizer, being put back into the watershed and washing back into our waterways. So that is an area of concern that has not been thoroughly studied yet as far as I'm aware. Next slide, please. So the work associated with this initiative builds on previous work by Wisconsin Sea Grant and Milwaukee Riverkeeper. So some of the things that Wisconsin Sea Grant has been doing really intentionally integrate sciences and humanities. So for example, plastic entanglements, ecology, aesthetics, materials was an art installation on exhibit between September 2019 and January 2020 at the Chatham Museum of Art on the University of Wisconsin-Madison campus. And Wisconsin Sea Grant staff created like pre and post field trip guides for educators to help explain the scientific concepts such as the chemistry of polymers associated with some of the exhibit pieces. Wisconsin Sea Grant and other partners such as the Center for Great Lakes Literacy and the Wisconsin Energy Institute designed the trash trunk and plastic panic educational kits. And these kits are available for free loan through the UW-Madison Water Library and a variety of other partners. More educational opportunities for teachers. And then the Play's the Thing was Wisconsin Sea Grant's first NOAA marine debris prevention grant. This effort once again integrated the arts and sciences, this time through the creation of a theatrical performance script that addressed 3 questions. What is marine debris? What are its impacts? And what can be done about it? And then you heard a little bit earlier from me about plastic-free MKE and plastic-free Cleveland and our systemic initiatives to try and reduce the harms that unnecessary single-use plastics have on environmental health, public health, and social justice. Next slide, please. So then while many of Wisconsin Sea Grant and Milwaukee Riverkeeper's previous projects were focusing on plastics of all sizes, this project is focusing specifically on microplastics. And the fashion industry was selected as a focal community for this initiative because of the potential impacts they may have by increasing education around microplastics as marine debris, affecting actual change in fashion design and clothing production, and thereby reducing the quantity of microplastic entering wastewater through laundry. Mount Mary University was selected because this institution provides an opportunity for Wisconsin Sea Grant to operationalize its commitment to working with historically marginalized populations. MMU is an all-women's federally recognized Hispanic serving institution founded in 1929, whose students are over 60% students of color, with Hispanics now representing the largest demographic group. And so this marine debris prevention initiative is going to build on MMU's commitment to supporting fashion education. It was the first university in the nation to develop a 4-year fashion degree program that continues to train the next generation of fashion designers. And sustainability and social justice by expanding on the work already being done through existing programming such as Leadership for Social Justice course, which each first-year student is required to take, and elective courses that promote zero waste pattern design and cutting, upcycling fabric, and textile design printing. So I'm going to turn it back over to Ginny.
So as I said, we've just pretty much begun pretty much with communication projects. Fortunately, some of that work has been picked up, and we were asked to present at the Larry Mueller Show, which is a syndicated show with Wisconsin Public Radio. I was featured as one of our projects, and a project that you'll be hearing about, another Wisconsin-based project we joined collaboratively. Next slide, please. And then some of our deliverables include the annual fashion show. We're hoping to have more products that are not made from polyester, but rather featuring some of the additional fabrics like fish leather and perhaps rayon and some of the other fabrics that the students might not otherwise have access to because of the cost. So the silk and the wool products are much more expensive to buy those fabrics. Also working with the faculty, we have a workshop scheduled on December 12th to encourage them to look at their curriculums, make changes to syllabi, and a lot of other smaller initiatives as well. So we'll be telling you a little bit more this time next year about our efforts. Thank you. Do we have any questions?
I can go quick, mine's fast. I was just curious if you guys recommend recycled fabrics like recycled polyester, or no, since they continue to leach microplastics, it might be more harmful.
So the primary recommendation is whatever you're wearing, keep wearing it, right? So if you own it, use it as long as you possibly can, extend its life as long as you possibly can. We're not recommending you go out and buy a brand new wardrobe. To your point of your question, however, there are industries that are recycling a variety of different products to make clothing, for example, fleece products out of recycled material. The same thing is happening, right? When you wash that, the little pieces of plastic are coming off in the laundry. So we might be solving one part of our plastic waste stream, but we're creating a new plastic waste stream. So our moral of our story is everywhere is somewhere, nowhere is away. And that's basically the gist of it, right? Everything you do has consequences, and we each have to make our personal choices as to what we can do in our particular situation to reduce our impacts.
Hi, so you said you were hosting a fashion show or some sort of, is that going to be so fashion students, is that like a project that students are going to do through an internship, or is it more through courses that they're taking? I'm wondering what the structure is of having students work on these projects.
Yeah, so again, we're relying on the strength of all of our partners. So Mount Mary University has an annual fashion show that they have been coordinating and hosting for years. One of their students' classes, a senior part of the class curriculum, hosts that, organizes it, does all of the runway management. They have marketing students that market that fashion show. So our particular project doesn't have to take on that aspect of it. Other groups on campus are already doing that. Our small part is to encourage this year less polyester in the show and really focusing on the messaging of the marine debris reduction through the hopefully smaller use of polyester fabrics in the future, and talking to the students about their choices as they're designing their products.
Earlier I mentioned the stuff swaps that Milwaukee, or that Plastic Free MKE is starting to do. We're actually going to have the students come to a stuff swap and like take pieces of clothing home that are being, so stuff swaps are like rehoming gently used clothing and household goods. So we'll have students come to a stuff swap and hopefully find some pieces that they will then incorporate into the fashion show. So really trying to build that community of reuse, not just throughout Milwaukee, but through the fashion department and through the students that are learning through that process.
And again, the university has a lot of initiatives already happening. So for example, they have a closet, a fabric closet, where materials are reused. So you might use a small piece of the fabric that has been purchased, and then the smaller pieces might become part of someone else's project. And again, we're, through the grant, able to buy some fabrics that are fairly expensive that the students wouldn't otherwise have access to.
Thank you. So a quick comment and a quick question. So for a few years now, I've been following the Icelandic Ocean Cluster, their 100% fish initiative, where they've created new markets for the whole cod, right? I think they're utilizing like 97% of that fish. Part of that was their fashion industry. You know, their runway models are wearing fish leather, and now everybody wants it. So brilliant concept. I'm so glad that you're adopting it, but I'm curious, where are you sourcing your fish leather from?
We haven't yet sourced it, so we will be figuring that out. Wisconsin also has a large commercial fishery. People don't really think of the Great Lakes as a fishery, but we have a whole program of Eat Wisconsin Fish. So we're hoping to be able to source some of it locally. We don't quite yet know. Again, we're just starting in our grant, and that'll be one of our next things for the spring semester and moving forward.
Great.
Thank you. That's all the time we have for questions. Thank you.
All right, next we have fish finders for stewardship, training volunteers to use side scan sonar to find and remove derelict crab pots from Delaware's recreational blue crab fishery by Trembanis.
Thank you. Good afternoon. I'm Trembanis, and I like blue crabs. If you like blue crabs, let me hear you say yeah.
Yeah.
I said, if you like blue crabs, let me hear you say yeah. Thank you. I feel like I'm falling, we thought Laverne and Shirley were the best thing to come out of Milwaukee. We'll move over. These two dynamic do. Okay, so I'm going to talk to you about our project. We can move to the next slide here. I represent part of our team. It's comprised of partnership between myself. I'm a professor at the University of Delaware. I specialize in robotics and seafloor mapping and kind of got pulled into this arena about 5 years ago. By a Delaware Sea Grant coastal ecologist, and I work with Brittany Haywoods, the co-PI on this, together with my postdoc, Cam Bodine. You can see some of Cam's work on the big poster out in the hall. Please come on by and I'll show you that, the Sonar system, and a partnership also with a number of volunteers and stakeholders in the community, and technology partners from some of the consumer sonar systems out there. Let's move to the next slide. So just welcome, say hello from the first state, and I'm going to take you on a trip to Delaware's inland bays. These are our shallow inland waterways. We have two major bays, Rehoboth Bay and Indian River Inlet Bay. So I'm not thinking about the principal Delaware Bay. They comprise about 20,000 acres. They're very shallow, and there tends to be this misconception that the only challenging seafloor mapping is deep ocean mapping, but shallow water mapping is really, really challenging. And these are very turbid and very shallow settings, average depth about 4 or 5 feet. And it's also one where, paradoxically or somewhat challengingly, this is entirely a recreational fishery. It's not commercial at all. So we're kind of suffering the tragedy of the commons here. Let's move on. And I won't belabor this. There's a whole host of reasons for things that cause loss of crab pots here and turn them into derelict or ghost pots. And then there's a whole variety of impacts that they have and that we've been studying for a number of years. So we'll get into that more later. Next slide, please. Okay, so the first time I went out in 2019 and turned on a sonar and started mapping in the inland bays, my jaw dropped. I knew we would find some pots, but when we turned it on and I calibrated my eye to saying, oh, well, that's a crab pot. Well, if that's a crab pot, then that's a crab pot. Then that's a crab pot. Then that's a crab pot. So this image, 2019, an area was about 200 acres. We found 260 some pots just in this area here. That works out to about 400 and some per kilometer squared. If you work up those averages, astounding densities, right? Accumulated over the years. You can see part of this map actually in the big poster out there. So, NOAA has this mantra we've adopted in our lab as well: map once and use many times. Even if you have these kind of consumer recreational sonars, which is why I asked Buzz about his, you turn these on and record your data. Now suddenly you can not only do object detection and find marine debris, but you can also do habitat mapping. There are subtle differences in the backscatter intensity. The dark areas there are muddier and the brighter areas are sandier. So you can also now start to look at habitat and habitat affinities for different species. Let's go to the next slide. So we saw a shocking number, and we realized, and it kind of got people saying, well, you've got to do something about it. Okay, we got kind of dragged into that. And we've done a number of roundups over the years. Most recently, last weekend, my back's still a little sore, my arms are still a little sore. We recovered over 2 days, 111 pots. We went back to Bay Cove in north side of Rehoboth. And this time it went from, we're seeing more than 240 pots, we saw 160 pots. So we'll get back to that later. Let's go to the next slide. Okay, so in addition to the sort of mapping efforts, we're doing a number of engaging residents activities through refurbishment workshops. We really want to encourage folks to be able to get out there and get crab pots. Let's go to the next slide here. Over 6 events, we've checked over 144 crab pots for folks, helping them to learn how properly to rig them, to include BRDs, bycatch reduction devices, cull rings, make sure that they're accounting for a tide and having enough rope and the right buoyancy for a float and all these kinds of good things. We want people to get their pots back because that's how they're going to get their crabs back. Okay, next slide. And a big component of what we're doing is we've done a couple of sonar training workshops, and we're developing some videos that we're going to make public for broadly the community of folks that are out there using this. Many boats now have fish finders, and these fish finders are bringing to them remarkable levels of sonar technology that just a few years ago would have cost tens of thousands of dollars, and now you can get on, and some boats have multiples on them. Multi-frequency, side imaging, down imaging, single beam, multi-beam. It's really, again, I'm a sonar nerd, so I'm really into these things. But we can now marshal a flotilla of people who can help us to map areas. Let's go to the next slide. So we're training folks. We've put together these mobile mapping units, so we have a sonar library that we can lend out. If you've got a boat and you're willing to help out, even if you don't have a sonar, we'll set you up with one. You can borrow it. You can help us go and map. It's a big area to map. 20,000 acres, it would take us about 200 days to map it all. So we need help. Okay, so we've got these. You can see one of those out there. Let's go to the next slide. And then we can quickly show folks how to recognize pots. They can mark the targets, or even better, if they record that data, we can then process it. Let's go to the next slide there. If you come and see the big poster, I can show you. You can, once you see a few, then it's like the Rosetta Stone. Some of you'll just see all the many around. So of course we thought, if we can teach people, can we teach AI to do it? And yes, it's a growing effort because we need more and more data, but we're building an AI system that can detect the crab pots. And what would take 90 minutes, an hour and a half to go process, the AI can do it in like 10 minutes. Let's go to the next slide. So this is what it looked like in 2024. Just this year, 160 pots, so not as many as we saw before, and then we knocked 111 out of here, so we're chipping away at it. Of course, then I'll show you in a second. Let's go to the next slide. So this was our first time, actually, again, we were able to put sonar systems on multiple boats. So we had boats marking, boats mapping, and boats recovering and hauling. And we could use the sonar to really improve the effectiveness of doing all of those activities. Go to the next slide. Of course, we thought, well, let's take a look nearby. And we were actually now able to both be doing recoveries and sort of bird dogging, mapping other areas. We went about a quarter mile away, spent a few hours, mapped, lo and behold, many more pots there. So we now have our hunting grounds for our next roundup sometime in the new year. Let's go to the next slide. So yeah, that's about our program, and I'm happy to answer any questions you might have. Thanks.
So, logistics question.
Sure.
When you have the locations for the traps, it seems like a couple of years ago I heard a discussion about this project before it had actually started, maybe before it was even funded. I think it was just a proposal at that point. It was at Sea Grant Week. And I think the idea at that point was that they were going to ask the volunteers to attach a buoy to the trap, and so that it could be retrieved later. Yes. Is that what they're doing now? And then how are the traps actually retrieved?
Yeah, absolutely. So it's kind of a 3-part process. The first step is we go out and we map the area, wide area survey, and my team or any other volunteers, we can do that, a few weeks before an event. And then in the day or two, the rate limiting step is marking to hauling. So now once we load these points, these waypoints onto somebody's sonar. We give them now a multi-beam imaging system so they can come right up to that pot, and then the first team goes out and marks. And they put a little line on, and we have permission to be able to leave those out. So we'll try to do those a day or two ahead of time to get ahead of the hauling boats. So then the hauling boats can come in with their davits and their strong backs and haul as many. And so if we get out ahead, that's what allowed us to get 111 in the 2 days. So we have mapping, marking, and then the hauling. Thank you for the presentation. Can you date the recovered traps? And if yes, is there, although it seems, given that reaction, maybe the answer isn't yes. Is there anything you can learn about manufacture, use, weather, or anything like that?
Yeah, so that's a great question. No, there's no sadly no born on date on these. Really the marking is only done on the buoy. So once we've lost the buoy, which is what inherently makes them ghost pots, we've kind of lost that identification. We can look for certain clues about maybe the composition, or did they have co-rings or BRDs, and when did that sort of come into being used. We're still learning lots about it. I mean, one of the things, if you notice, is we're seeing, and there's a reason I asked Buzz about habitat types, is we're tending to see more of them in the muddier substrates. And so people don't have these maps to know. And I think they're just going out and putting pots down, and they come back a couple of days, if it's in the mud and you're trying to pull it out, and then you go, boy, I better not leave this here, I'm gonna get in trouble, or are they moving? Are they drifting from the sandier areas and ending up in mud? So we got a lot of questions about those, but we're seeing that they're continuing to fish. We've done some studies where we've put pots near, and this is the unfortunate thing too, is if you put out a crab pot and there's a ghost pot there, crab doesn't know or care. In fact, it might be more attractive to go into the ghost pot. And so we're seeing that we've run some economic studies that each of those ghost pots is accounting for about $260 worth of blue crab loss. And if we look at those densities in the area of the inland bays, it could be upwards of $5 million every year in just crabs that aren't ending up with anybody.
Could I, so a follow-up question? So simple question again. What's the material that these crab pots are made of, and what do you do with them after you haul it?
Yeah, great question. So they're kind of a metal wire, metal cage with funnels on them. The ones that are in good condition, we wash them off. We make them available to folks. Again, these are recreational, so most of the time, it might be somebody coming on the weekend, they've lost a pot. We don't have any way to really trace it back to them, but we make those available. The ones that are really, messed up or deteriorated, we do some partnership where we might make those available to get crushed down and used as a base for oysters or other, green infrastructure type things.
Quick question. Does the side sonar work in the muddy bottom?
Yeah, absolutely. You get a darker return because there's less of that energy coming back, but we can very clearly see those areas of muddy bottoms. You get side imaging, down imaging, single beam, and so that allows us then to consider, we can then use these same data sets to look at some of those substrate habitats as well. It works well in those muddy areas and in contrast to sandier or rocky places.
Thank you, Art. We'll move on to the next presenter.
All right, next we have Massachusetts Marine Debris from Source to Stellwagen, a comprehensive suite of tools for environmental educators by Kristi, Burkholder, and Bray.
Hey everybody, art is a hard act to follow. I feel like I need to get everybody cheering for student drifters or something like that, but I don't think it has quite the same cachet as blue crabs. So thank you so much for the attention today. My name is Kristi Burkholder. I'm an oceanographer and professor at Stonehill College, which is a small school outside of Boston. I'm joined by my colleague Bray, who's here from MIT Sea Grant. And we're going to be talking about the work that we've been doing, building tools for educators to use in their classrooms to talk about marine debris. And also Ben and I wanted to acknowledge that we are part of a 4-person team right from the beginning of this grant. And so this work would not have been possible without the combined efforts of our colleagues, Drew Bennett and Jack Buckley. Next slide. Okay, so the approach that our grant team has taken is that we really focused our grant around 3 central pillars. First, we wanted to build new tools. Second, we wanted to think about how to implement those tools in classrooms. And then finally, we wanted to figure out how to continue the work with our students after they completed a marine debris curriculum. Next slide. And one more. Okay,
So the first pillar was to talk about how we were building new tools that educators could use to talk about marine debris. And when we thought about what tools we might want to have available to educators, the first thing that came to our mind was satellite tracked surface drifters, which can be used to help model the flow of marine debris in the ocean. Now, we were very fortunate that in the Gulf of Maine, there was already a robust student drifter program operating. There had been a program called the Student Drifter Program, whose website is listed on the slide. But the Student Drifter Program had been operating for decades in the Gulf of Maine, and it's this amazing program that partners K-12 students who build drifters in their classroom with commercial fishermen who deploy the drifters. You can see a couple of our drifters up on top of a commercial boat, bringing the drifters offshore, and then scientists and educators who use the data from those drifters in their classrooms and in their research labs. So when we were thinking about revamping our program and building new tools for educators to use, we had a great starting point, but we wanted to work with the Student Drifter Program to think about how we might update their drifters. And our collaborators at the Student Drifter Program really pointed to three things. First, the materials that were used to construct the drifters were not necessarily sustainable. You'll notice that the flotation for the drifters was actually out of styrofoam. Second, the drifters cost more than $1,000 each, which made them cost prohibitive for some school districts. And finally, they were a little bit bulky and hard to ship, which meant that school districts away from the coast really had a hard time accessing the program. Next slide. Thank you. And so the work of Drew Bennett at MIT Stu Grant over the last year has been to develop a new and sort of improved drifter. And as you can see from the column on the right on the slide, Drew has improved by a number of metrics on the old drifter. So notably, he's designed the drifters to be made of more sustainable materials. So the flotation for the new drifters is actually from pumice stones. The drifter cost has been slashed to about $250 per drifter. And finally, as you can see in the picture on the right, he's designed the drifter to be foldable, which means that any school district in the Commonwealth could theoretically participate in the program, ship the drifter to the dock, and then be able to track it remotely. Next slide. And so the next steps for Drew is that he's going to be testing his new drifters in the ocean. He's been in the MIT Wave tank up until this point. And he's also working on designing drifters that have a number of different geometries so that he can better model things like a plastic bottle or a cargo ship, or sorry, a cargo container as it moves through the water. Next slide.
So to visualize these drifters, and to visualize the flow of debris from land to ocean, we developed a web-based marine debris interface. This mobile-friendly interface presents the flow of debris as a series of steps and tools. Each step has instructions for visualizing data and includes a summary of the data sources and tools being used. You can use the interface to query the debris tracker directly, the debris tracker database directly, and visualize the reported debris. Then you can use the Draw Watershed feature to get some idea of where the debris you visualize may have come from and following the natural topography of the land. And once you have a watershed, once you've drawn a watershed, you can use the trace downstream feature to visualize the flow of debris to the ocean, also following the natural topography of the land. Finally, you can visualize the tracks of all the student drifters to get a sense of where the debris may travel once it reaches the ocean. You can also use the interface to visualize currents, sea surface temperature, and other relevant data from its vast set of data sources to see how the flow of debris is influenced by various environmental sources. We built the interface using the Seaglass programming framework developed by MIT Sea Grant. Seaglass is a mobile-friendly web framework for data management, visualization, analysis, modeling, and download. The system utilizes a dynamic and flexible ensemble of internal and external data sources, including APIs, including its own database as well, to which users can upload their data. External data sources include map server layers and raster data from satellites, as well as data sets for buoys, drifters, and ship tracks. The framework includes a vast set of visualization methods and tools which can be customized and added to new interfaces per use case. In addition to visualizing data, the system also supports index calculation, modeling, and output visualization. And all visualized and modeled output can be downloaded from the system on the fly as tabular or graphical files.
If you could go forward 2 slides, that would be great. Thank you. All right, so once we had the tools, we then set out to figure out how to incorporate those into the classroom. Next slide. And to do that, we went right to the source. So in 2023-2024 school year, we worked with a pilot cohort of 6 teachers who come to us from K-12 districts. And we trained them up over the course of 3 workshops during the academic year to learn how to use the new tools. Our ask of the teachers was then that they design grade level appropriate lessons and activities that incorporate those tools, and that they share them back with us. So we'll be making those publicly available in the years to come. One of the coolest things that ended up happening at the end of the year was that we had the opportunity to bring the students, next slide, to Stonehill to present the work of some of the things that they had been up to in their classroom. And as you can see on the bottom, we also went mobile to meet with the 3rd graders since we couldn't bring the 3rd graders to us on campus. Next slide. And the final, oh, sorry, one more. Next slide. Thank you. And the final thing that we were working on is thinking about how to extend the work with our students once they finish our program. Next slide. And so in summer 2024, we started the process of connecting with different groups in Boston, including the Calculus Project, to continue our work with hosting marine debris workshops, but also thinking through how to engage Boston area high school students in an internship program. Next slide. And so the next steps for us is that in the next couple of years, we're going to be hosting a summer internship program focused on marine debris. We won't actually be hosting the interns ourselves, but we'll be setting up a support system for interns so that they have financial support from us to be able to lower barriers that they might face in doing an internship, whether that's transportation to a site, whether that's having access to gear that they might need to be able to do the internship, etc. We're really looking to meet the students where they are with this program. And so with that, I'll go to our final slide and just thank our funding agencies and our partners, and we would welcome any questions. Thank you so much.
Yeah, it's really great to see your activities as a person who worked on fluid mechanics at MIT and who teaches calculus.
Oh, great.
Yeah, so I'm wondering about how you actually tracked those the samples you flew into the ocean and then recycle those things, or if you have any kind of a plan for using the biodegradable materials. If you cannot track all of them, I would appreciate if you share those thoughts.
Yeah, by the particles, you mean the student drifters? Yeah, that's an excellent question. And so the student drifter program, believe it or not, has been operational for a couple of decades at least. I believe they began in the early 2000s. And over that time, they've launched over 1,100 drifters that have become part of that student drifter database. And as you suggest, the recovery rate for those drifters is only about 50%. So we track them. They all have GPS trackers on top of them. And so we're actually able, through the sea glass and through a couple of different methods, to visualize those flows. We actually still have 3 that were launched as part of our pilot cohort in the water right now. So if you go to the website, you can check that out. But you're absolutely right. So one of our big concerns was that if we're losing 50% of the drifters, while we're studying marine debris, we're actually creating marine debris, which really didn't feel right. And that was one of the big motivators for working with Drew at MIT Sea Grant on developing a more sustainable drifter, so that in the event that we do lose it, we're not adding to the problem in the way that we once were. Thank you for the question.
I think I missed, what is the point of the drifters? Is it to see where the currents will bring the plastics, or is it to catch some of the plastics?
Yeah, that's a great question too. So the title of our grant is actually, or maybe the subtitle is From Source to Stellwagen. And so we were really trying to help students to understand the sort of complete cycle of marine debris. So we start with the students using the Marine Debris Tracker app in their outside of their schools,
finding debris there. Using Ben's tool, they could track how that debris makes its way into the ocean. And then the drifters allow us to show the students that once debris makes it into the ocean, it doesn't necessarily end there. It can end up all over in different places, including in places like Stellwagen Bank, which is a really treasured area for a lot of Massachusetts students. And so we're using the drifters within the context of the marine debris grant to help students understand the fate of where debris might go in the ocean once it's in the water. But as an oceanographer, I will also tell you that we use these drifters for oceanographic reasons as well. So I've made use of the student drifter data set over the last 25 years, 30 years of its history to look at how currents are changing in the Gulf of Maine, for example, over time.
Hi. How did you go about reaching out to and recruiting teachers for your pilot program?
Excellent question. So I have to give all credit on that one to my colleague, Jack Buckley, who works at the Cohasset Center for Student Coastal Research. Jack's a part of a number of different Boston educator networks. And so when we started reaching out to students, he was going to a number of workshops with a lot of Boston area school districts and public school teachers and did a lot of the outreach that way. We had an email advertisement that we sent out to teachers, et cetera. But we also wrote into the grant a $1,000 stipend for each of our K-12 teacher partners, which covered the fact that they were giving up 3 Saturdays to come and get trained with us, but also that they were giving us their intellectual property, coming up with lesson plans, and many of them were specifying like which state standards their lessons were meeting, the activities they designed, things like that. And they were handing those over for us to make public to other teachers that might be interested as well. So I think that was a carrot that maybe helped us get a higher response rate from some of the teachers than we might otherwise have been able to get.
Thank you so much. We're going to move on to the next presenter.
Thank you.
All right, and last but certainly not least, raising awareness of marine pollution in underserved populations, or RAMP Up, from Maurice Crawford.
Thank you, everyone. Great to be here. My name is Maurice Crawford, and I'm from Maryland Sea Grant. And I want to share with you an update on the marine debris grant that we received. The title of our grant is Raising Awareness About Marine Pollution in Underserved Populations. And of course, I want to recognize my other team members, Frederica Mosier, Maryland Sea Grant, Maggie Sexton from the University of Maryland Eastern Shore, and Joy Riceley at Hampton University. Next slide, please. So this is the overall goal of the project. We're going out into the community and working with students at 2 undergraduate universities and teaching them about marine debris and getting them to think about how that marine debris issue is connected with environmental justice and actions that they can take. Next slide, please. So when I think about the grant, I'm always thinking about ways I can connect with the students, and I use this ocean literacy principle number 6. We are connected to the ocean. Some ways it's very obvious how we're connected to the oceans, and other ways it's much more subtle. So when I'm out into the community talking to my students, I talk about marine debris, and then I like talk about plastic pollution. Plastic pollution is a little bit better way of connecting with the students. Tell them what it is, why it's important, the effects it can have, and the effects it can have upon them. Next slide, please. The way we do this is we have 2 parts to the grant. One part of the grant is formal education, working at 2 academic institutions. And the second part of the grant is informal education, working with different institutions that have summer programs for youth. And I'm going to talk about each of these in turn. So first we'll do the formal education, and then second we'll talk about informal education. Next slide, please. Oh, there it is. So my 2 partners are at the University of Maryland Eastern Shore and Hampton University. Both of these universities are historically Black schools. And what we're doing with these institutions is Maggie and Joey, they're developing modules around marine debris that they use in the courses that they teach. And I'm defining marine debris quite broadly here, everything from microplastics to ghost pots to derelict fishing gear. When they create a module, the module includes things like your slides, questions for the students, ways to assess the students, readings and homework assignments. So it's a pretty nice little package that you can use. And below I have some of the modules we created. I created one on environmental justice, one on ecology of marine debris, and one on the cost of marine debris. So these are kind of the modules that we're doing at the formal education level. Next slide. In addition to those activities, my colleagues do other things. So for example, Maggie at University of Maryland Shore, she has a research experience for undergraduates grant from NSF. And during that 12-week program, the students are with her, they go out and they do a beach cleanup. And then they add that data up to the Ocean Conservancy's app. Now, a couple of weeks ago, Joey Riceley, his students, they were at the Virginia Beach Aquarium for Fright Night. This is an event they have every Halloween. A lot of people come into the aquarium. And Joey and his students, they had a little table where they talked about marine debris. And they had an example of a ghost pot. You see that pot on the far right-hand side? That's what ghost pots do. They capture ghosts, right? So that's what they're doing. Next slide, please. So in terms of the informal education, I work with these different programs that have summer activities for youth, right? These are the programs I work with this past summer: Living Classrooms Foundation, Annapolis Rec and Parks, Eco Latinos, and Morgan State University. And the way this works is usually about March and April, I'll start going out in the community, talking to people, saying, oh, I hear you have a summer program for youth. I'm interested in marine debris issues. I can come over and I can do X, Y, and Z with you. And so we'll have a conversation back and forth because every program is a little bit different, right? I'll give you an example. Next slide, please. So this is a program I did with the Living Classrooms Foundation. They have a program with 6 students. It's called a Junior Ranger program. They're based on Kingman Island in Washington, D.C. They meet Monday through Fridays between 9 a.m. and 1 p.m. So that's the parameters I have to work with. I want to get the students out into the world, right? So we went and visited the recycling center for Prince George's County. Big recycling center in Capitol Heights. All that stuff comes in garbage trucks, goes up a conveyor belt, gets sorted. They have catwalks, everything's behind a glass wall. It's all set up for people to look at. So we took them over there so they can see what happens to the recycling. Also, they got a chance to learn about microplastics up at the National Institutes for Standards and Technology Lab in Gaithersburg. And we also had a little fun time going over to one of their locations where they meet. And I talked to them about marine debris and recycling issues. Next slide, please. So here's a picture of what we did. I have 2 minutes left. Oh my gosh. So the picture on the far left, that's us visiting the recycling center in Capitol Heights, Maryland. Over on the right is when we visited the NIST lab. This was a visit with George Caceres. He's actually a PhD student at the University of Maryland, and he's working on microplastics. So students went to his lab and they saw microplastics. Really, really interesting because they see how small these things are, and then they realize how ubiquitous they are in the environment. And they start asking you questions. Well, if they're all over the place, are they in me? Yeah. Next slide. Another group that I worked with was Eco Latinos. I worked with my colleague Adam Frederick, and we went up to the Institute of Marine Environment Technology in Baltimore. Adam puts out in the environment these little discs, and these discs capture all sorts of things settle on those discs. And if you look closely, you'll find microfibers and microplastics on those discs. So the students were able to actually see that in the lab. Next slide, please. So when you talk about, when I'm out into the world talking to the students, talk about plastic pollution, that resonates because everyone knows what plastic is. Talk about microplastics, and they'll make the connection between the two, and they'll be more motivated to think about what does it mean, what they can do about it. And the next slide. If you have any questions, that's my email address. All right. Speak loud.
Okay, there we go. Hi, thank you for that. Great project. I'm curious though, my experience has been that the terminology or the reference to marine debris isn't necessarily relatable to children and adults. And if you, not to throw Noah under the bus or anything, but when you go to the official definition, it's quite long and just long. Have you encountered that? And it seems like you're using specifics like plastic pollution. Like, what are some of the things or terminologies or phrases or ways that you're making it relatable to different audiences in different contexts?
Yeah, so, I used to work in this building 20 years ago. So I have to acknowledge Noah, and, they're paying my salary. And so I use their debris term that they give. When I'm out talking to the junior rangers, I have the definition of marine debris, right? And it's written up there so they can see it. And then from there, I talk about how most of marine debris is mostly plastic. And then I don't use that term marine debris anymore. I talk about plastic pollution because everyone knows they've seen plastic bags floating down the street. They can relate to that quite easily. Marine debris is a little bit more, it's hard for them to get their heads around it. So I use the term plastic pollution. And I like to get the students into different people's labs with microplastics because then they realize how much of a problem it really is because it has an effect upon their health. And we don't know what those microplastics in our body are actually doing, but I'm guessing in the end, it's probably not anything good for us. Any other questions?
Hi, yeah, great presentation. I was just curious, all of those resources, those educational workshops that you guys have been working on, are those available online? Or I'm curious if you have like a repository for them.
Yeah, I'm throwing everything up onto Google Drive. So right now they're not public. So I'll give you an example. The environmental justice module I put together, Maggie tried it out in her class last fall. And then at the beginning of the spring semester, we revised it. And she's joining it again this fall. So after this second run, we'll probably revise it again. And then I'll probably put it out somewhere where people can get it. I went to the National Marine Education Association meeting. Some of you were there. I know we saw each other in the same session. And I saw, all these little QPR codes out there. I said, what a great idea. So if I go to that meeting in Mississippi next year, I'll probably have a QPR code where people can just get access to that material. But my intention, is to make it public. Yep.
Time for one really quick question. If we don't, I have a question for you. What has been your favorite part about working on this project?
My favorite part about working, I really like going into the labs where students can actually see the microplastics because it really opens their eyes. Yeah, that's my favorite part of the project. And just like walking around the woods with students, I like being outside. So.
Sounds great. Thank you so much. So that was our last presentation for the day. Let's hear it for everyone. So if you can go to the next slide real quick. So this wraps up our virtual portion of day one, and we will reconvene for day two at 8:30 a.m. tomorrow. Next slide, please. For those of you in person, we will be starting our networking and collaborative conversations
in the Science Center across the hall. Since we ran a little over time, let's reconvene there at 3:45. Thank you, everyone.